Welcome guys, today I'm going to show you how to count up Bohr's atom model in a simpler way. Well, not exactly simpler, but in a way you'll understand better. So here is the basic Bohr's atom model. There can be at a maximum of 7 shells in one atom. The first shell is also called the first energy level. It's called K. The second energy level is L. The third is M. Fourth is N. Fifth is O. Sixth is P. And seventh is Q. And over here, I have the maximum number of electrons for each shell. Shell K can have at most 2 electrons. L can have 8 at most. M can hold 18 at most. N has 32 at most. O has 32 at most as well. P has 18 at most, and Q can hold a maximum of 8. So for example, let's try the Bohr's model of nature of sodium. The atomic number is 11, so let's see. It's the first shell, 2 electrons, plus 8 electrons is 10. So 2, 8. That's the maximum number of electrons for K and L. It's 2, 8, and 1. Add all 3 of these together and you get the atomic number. So that's pretty much the gist of it. But then you have the Bohr's model of Kalium, which has the atomic number of 19. Same deal again. 2 plus 8 plus 8 plus 1. Now this might be a little confusing because you'll be thinking, but wait a minute, shouldn't it be 2, then 8, then 9? Because M can hold 18 electrons, shouldn't it be like this? Actually, no, for reasons that I will soon explain. Then the third one, we have Bohr's model of zinc, which has an atomic number of 30, which is 2, 8, 18, and 2. I add all these together and you get 30. Now you might be confused again as to why this can be 18 this time. All right, there's actually a method to this confusing thing. A method that you might understand better. I know I do. Normally, I use the electronic configuration to make this better. The electronic configuration is a way of distributing electrons among orbitals. There are 4 sublevels or subshells in each shell of an atom, like the Bohr's model here. This is one shell, and there can be up to 4 subshells within that one shell. So we add it according to the maximum limit. K can hold 2 electrons at most, so K at the first energy level can only hold 1 S because the subshell here. Let me explain the 4 subshells first. First, we have the subshell called sharp, or S for short, can hold 2 electrons at most. 2 electrons means 1 orbital. Then at the second subshell, we have principal, also known as P. The maximum electrons it has is 6, which means 3 orbitals. The third one is diffuse, or D for short, can hold 10 with 5 orbitals. And the last one is fundamental, or F. It can hold 14 with 7 orbitals. Now for each shell, L can have 8 electrons at most, so we add them together. L has subshells of 2s and 2p, because 2 plus 6 is 8. Now this is the model of the electronic configuration. From 1s, you draw a line, then you continue up here to 2s, you draw another line, goes back up here to p to 3s, again to 3p to 4s, to 3d, 4p, 5s, back up again, 4d, 5p, 6s, back up again, 4f, 5p, 6p, 7s, and back up again to 5f, 6d, and 7p. Now let's use the same examples as the Bohr's model. So for sodium, we start with 1s2. So that's 2 electrons. Then what's next? We have 2s2. Then up again, 2p6, add them all together is 10. We need one more. So we'll grab it from 3s1. To get this, 1s2, 2s2, 2p6, and 3s1. So now you know the electronic configuration, but how does that convert into the Bohr's model? Well, you see, look at this. 1s2, all right? So here, 1s2, it means that on the first shell, there are 2 electrons. Then you get to 2s2, 2s2, and 2p6. You get 8 electrons. And for the last one, you have 3s1. And from here, you have 1 electron. So now we have the first shell, second shell, third shell. First shell is 2, second shell is 8, and third shell is 1, resulting in the Bohr's model of 2, 8, 1. Alright, and then now for Kalium, let's see. 1s2 is 2 electrons, or E-min for short. Then 2s2 and 2p6 with 8 electrons. And then 3s2 and 3p6 which means another 8 electrons. And then you have 4s2 where you get 2 electrons. So now you have the first shell with 2 electrons, second shell 8, third shell 8, and fourth shell 2. So you get 2, 8, 8, 1. Wait. Sorry about that. This should be 4s1 with 1 electron. That's 2, 8, 8, 1. So now you're not too confused, right? It's the same principle for 30 zinc. So 1s2 is 2 electrons, 2s2, 2p6 is 8, 3s2, 3p6 is another 8, 4s2 is 2, and then now we have 3d10. So now 2 plus 6 plus 10 is 18. So we get the first shell has 2, second shell has 8, third shell has 18, and the fourth shell has 2. So we get 2, 8, 18, and 2. All right, so now let's get to the real business here, an exercise. The first one is 38 strontium. So first, let's start with the electronic configuration. You always start with 1s2. Then you continue on with 2s2, 2p6, 3s2, 3p6, until you get to the number 38. So far, this is 2 plus 2 plus 6 plus 2 plus 6. So that's around about 18. Continue to 4s2, 20, 3d10, makes it 30, and then 4p6, right? Makes it 36. Now 5s2. And now you have a perfect 38 right here. So now let's total up the shells. So in the first shell you have 2, second shell you have 2 plus 6, so 8. Third shell you have 2 plus 6 plus 10, makes it 18. Fourth shell you have 2 plus 6, which means 8. And then 5s2, you have 2 electrons. So now you have both the electronic configuration and the Bohr's model over here. Next up, you have francium, 87 francium. Let's start. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3b10, 4p6, then we have 5s2. Alright, so we've reached a checkpoint here, 38. Alright, so what's next? Then you have 4d. 4d10, then you have 5p6. Let's check again. We know until here it's 38, so this makes 48, 54. Not close yet. Keep going. Another 6s2. So 38, 48, 54. This is 56. Now we go to 4f. 4f has a maximum electron count of 14. So now we go for F 14. Now we have 70. At the 4F is 5D. 5D10. Which makes it 80. Now 7 more. 5D, then 6P. 6P6, then 7S1. Now we tally up the subshells. First shell we have 2, second shell we have 8, third shell we have 18, fourth shell we have 2 plus 6 plus 10 plus 14. Now it's 32. Fifth shell we have 2 plus 6 plus 10. So that's 18. And then the sixth shell you have 6s2 and 6p6, so 2 plus 6 is 8. Now the seventh shell is only 1. So far so good? I sure do hope so. Let's make a new one. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3b10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14. Then we have 5d10, 6p6, and 7s1. Now you might be wondering why I went this far, but this makes it easier. So 88, 87 francium is until 7s1. Now we want to go for 82. So you minus 5. This is minus 1. Then you take 4 more from 6p6, making it 6p2. Now let's count up the shells. First shell has 2. Second shell has 2 plus 6 is 8. Third shell has 18. Fourth shell has 2 plus 6 plus 10 plus 14, so it's still 32. The fifth shell has 2 plus 6 plus 10 is 18. And finally, we have the sixth shell, which only has 2 plus 2, 4. So that's the Bohr's model for this element. It's 2, 8, 18, 32, 18, and 4. Then we have this, then we have another one until 37. Let's go. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. If you keep doing this for long enough, you start to remember things. Like when you reach 4s2, that's number 20. Then 3d10 makes it 30. Then 4p6 makes it 36. Now after 4p6, we get 5s1. Tally up. The first shell has 2. Second shell has 8. Third shell has 2 plus 6 plus 10, which is 18. Fourth shell has 2 plus 6, 8. This shell only has 1. Now I prepared a final question here, which is quite tough because it reaches the number 114. So let's take this slowly. Let's start off by 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Let's lengthen this. And then it's 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, 4f14, 5d10, 6p6, 7s2. The 7s1 is 87, and 7s2 is now 88. So now from 7s2 to 5f14. 5f14, which means this is now 102, then 6010, making this 112, and now 7p4, which is the final number because this is 114, should be. Let's tally up 2 plus 2, 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 again is 20, plus 10, 30, plus 6, 36, plus 2 is 38, plus 10, 48, plus 6, 54, plus 2, 56, plus 14 is 70, 70 plus 10 is 80, then here is 86, 88, 102, 112, and this should be 7p2. So that is the correct version of it. Alright, now let's total up the shells. First shell is 2, second shell is 8, third shell is 18, fourth shell is 32, the fifth shell is 2 plus 6 plus 10 plus 14, so 32. The sixth shell is 2 plus 6 plus 10, so plus 18. And finally, the seventh shell is 2 plus 2, 4. So now, we're done with the entire exercise. All right, that's all I have to explain to you today. I hope you understand. I hope you understood the lesson. And goodbye.